entropy change in a reversible process is zero. That is why a reversible adiabatic process is known as isoentropic process. That means throughout the adiabatic process, if it is reversible, the net change in entropy is zero. Why is it so? It is so because heat transfer in adiabatic process equals to zero. That is why if you apply a formula for entropy change delta S system Q by T, then Q reversible equals to 0. So, 0 by T is 0. Similarly, if you apply the same formula for entropy change of the surrounding Q by T, again Q reversible for adiabatic process equals to 0. So, 0 upon something equals to 0. For reversible adiabatic process, entropy change equals to 0. So, reversible adiabatic process, we need to remember that for adiabatic reversible process, entropy change equals to 0. That is what has been mentioned over here. If you take entropy change for the system as Q by T, and for the surrounding you take minus Q by T, you add both of them, Q by T plus in the brackets minus Q by T, you will get 0. So, entropy change of the system plus surrounding equals to 0. So, overall entropy change of the new universe equals to 0 for reversible thermodynamic process. Mostly we are talking about adiabatic process. Now, if we take irreversible process, so what happens is, if you take entropy change of the system and you take the value as minus Q by T1, and for the entropy change of the surrounding you take plus Q by T2. Alright, minus Q by T1 for the entropy change of the system and plus Q by T2 entropy change of the surrounding. And for adiabatic process during expansion, for adiabatic process during expansion of gas, cooling occurs. That means temperature, initial temperature will be greater than final temperature. Alright. So, when you derive, you get this derivation that entropy change of the complete process will be equals to Q into T1 minus T2 by T1 into T2. So, if T1 is greater than T2, then what you get, T1 minus T2, you get this value as positive, right. So, the overall value for delta S entropy change of the process equals to Q into T1 minus T2 by T1 into T2. So, if this value is positive, this value is positive, so overall value will be positive. Alright. So, entropy change of the complete process is positive if the process is irreversible. This is happening in the irreversible process. So, in the reversible process, in adiabatic conditions, in reversible process delta S equals to 0, but in the reversible process delta S equals to positive. That means entropy is increasing. That is what second law of thermodynamics also says, that in an irreversible naturally occurring process, entropy of the universe keeps on increasing. That is what we are getting over here as well. Alright. Next we have few formulas which you can apply for solving problems, such as in isochoric process where volume is constant, for entropy change delta S you will apply NCV log T2 by T1, and if you are taking to the base C, for that we will take as NCV ln log V2 by T2 by T1, and similarly at constant pressure, that means isobaric process, you will calculate as NCP ln T2 by T1. And what about isothermal process? In an isothermal process, entropy change will be NR ln V2 by V1 or NR ln P1 by P2. So, this is the formula for isothermal change, NR ln V2 by V1 if volume is changing, and NR ln P1 by P2 if pressure is changing. We are taking natural log. If you want to take log to the base 10, you will take the formula in isothermal process as 2.303 log V2 by V1, or 2.303 and R log P1 by P2, right? So these are formulas. If a formula is having two processes, then you add the formulas of two processes simultaneously. All right. For example, we have over here you are adding a formula for isochoric process as well as isothermal process, because both the processes are happening simultaneously. All right. So these are few formulas which you need to remember and use wherever the case says for. For example, isothermal, use this formula. For isobaric, use this formula. For isochoric, use this formula. And for what about physical change? If boiling point is there, then use this formula, delta S equals to enthalpy of vaporization upon boiling point. And similarly for melting point, apply enthalpy of fusion, delta H fusion upon melting point. So using these formulas, you can easily calculate entropy change in your problems. That's it.